Uh, Hello. Everybody can hear me? Yes, cool. Yes, thank you. Hi, I'm Rico. I'm Rico Ling. I'm working at EasyStack. And Zen, you want to introduce yourself?
Hi, I'm Zane Bitter. I'm a member of the technical committee for OpenStack and long-time Heat developer.
Yeah. And I'm PTO, by the way. And so today we would like to talk about to improve to share some improvements in the OpenStack integration for application developer. We're gonna first to define what is an application developer for us. What's the meaning for us? And we're trying to after these sessions, we kind of hope that everybody get the clear view what is the new generation technology we have in OpenStack for you, and what is not there for you, and we're trying, and where is the crazy idea we have. An application. So what is an application means? That means for OpenStack, everything built on top of OpenStack in certain way should be considered as an application. Like what you want to do maybe for, you can hear nowadays for IoT, for 5G network, you hear a lot of awesome, crazy stuff in the keynote, and those are applications for us. So who is an application developer? Whoever like writing the code for their own product, for the services, and keep getting ping for every time the service get crashed, will be by definition is the developer. And so you have to build your infrastructure, your application infrastructure on top of OpenStack infrastructure. That means you will start to think about how OpenStack, I mean, the new world will be how open infrastructure do for you and do for your application. Like you're thinking about, even when you're thinking about you want to have a database service, but when you're trying to have a database service, you don't want it to get crashed. You don't want it to get unsolid. You want to be well maintainable from through time, and you want to be able to keep innovate the application. I mean, like the version 1, the version 2, and you don't want to get bother every time that your application crashed because something beneath it, like the infrastructure, getting crushed. So
Rico, would you consider something like Kubernetes an application?
For a certain way, no. But you see, Kubernetes is one of the way you build your applications. But it's part, for us, is considered part of the application.
I think it depends where you look from, right? Because if you're at the application level looking down, Kubernetes looks like part of the infrastructure.
It is.
But if you're at the OpenStack level looking up, then it looks like part of the application.
Indeed. But you see, how as an OpenStack developer can define what is OpenStack and what is applications. So Kubernetes is like something built beneath it. Something on top of it. And sometimes Kubernetes go beneath the OpenStack infrastructure. But for us, we consider Kubernetes as part of applications in terms of it is something you require to build your application. Why? Because your application, what we mentioned, might be a MySQL server. It is on top of a container, right? You might running inside a pod. That's why we might consider Kubernetes as a part of application, but might not. But for me, personally, I think it is part of our application, will be fine.
So spoiler alert, a lot of things we're going to be talking about today are equally applicable to running Kubernetes on top of OpenStack. Just purely the Kubernetes layer dealing with OpenStack, it kind of requires some of the same things as applications running.
Exactly.
Directly.
if you see the new user survey, you see the Kubernetes is wow, like I don't know how many people are using Kubernetes for the application, but you can see the percentage. Almost most of OpenStack, a lot of the developer develop their service on top of OpenStack is using Kubernetes. So definitely. So let's talk about where it needs to be improved. In like a more higher level of concept, one is cross-community integration. What I mean, like what we have just give the very good example. Kubernetes is another community which is huge as OpenStack, but how can we integrate the two community effort like to achieve your daily require to achieve the best performance and best quality for your service, right? You, as an application developer, you really don't care your infrastructure detail, but you have no choice to see how to integrate with it. And for us, our responsibility is how we can help as a infrastructure developer, how we can help you to integrate the OpenStack and Kubernetes without just telling you just go to Kubernetes community get something, or you just go to OpenStack community to get something. That's whose responsibility. No, that's not kind of a thing we're going to tell to you. And the other thing for cross-project integration, if you have been in OpenStack for a long time, or you have to try to build your product on top of OpenStack, every time you have some issues, you feel you have to feedback to the OpenStack community, but always is a scenario, and it always is a cross-project. And sometimes you will feel you will hack the experience to integrate your feature into OpenStack community, but sometimes not. You might want to get some feature in Nova, but it happens to be Nova plus Cinder feature, which you require a cross-community work. And that's why we think to have a cross-project improvements is important. And it indeed still today need to be improved. Because we from time to time, as upstream developer, we heard from a new user, she or he might be a new developer or a new operator, to complain about they got some very brilliant idea, but they feel very painful to in touch with the community. But that is a brilliant idea we have to give, right? And on the other hand, there is a very great, brilliant operator. They got a very smart architecture, but they just don't know what is there, like cross-projectly already implemented for land or on the way, because who can have the knowledge to know that much project? So that is something we think that is definitely need to be improved. And the third is the cross-site and platform integration. So you might have a small OpenStack running, which usually not, because we're talking about OpenStack is usually heavy user, big cloud, or like telecom cloud, or unless you might want to have your own data center, unless like a lot of user is at less scale to actually require an OpenStack to integrate it. So like multi-region, multi-site. If I have two OpenStack, how can I do? Do I, as an application developer on top of this infrastructure, just do everything by myself? Then you are become an infrastructure developer. You become us, which is not what you needed. So to think about now today, the cross-site and platform integration in community, we will say still on the way in certain rights. Then you think? The cross-site and cross-platform ability for entire OpenStack community is still underdeveloped.
Yeah, it's a mixed bag, I think you would say.
Yeah.
So, some parts are there and some parts are still on the way.
Exactly, right? And sometimes you got some feature, you look into it and it's there, and sometimes like you have like cross-site, cross-platform OpenStack running, and you got new requirements, and this time the new feature is not there, and which is something that we definitely think it need to be improved. And the community improvement is about, like what we just gave you an example. I think a lot of people here might have experience, since you might be a real application developer, you have experience on engage with upstream. But that experience, like what we mentioned, some use cases might not be actually that good. And some certain use cases say he or she feel bad about trying to join the community because they got turned off. And as a community, how can we help to improve this kind of experience? Unfortunate to say that nowadays we still trying to find more ways to improve the community, and so that's definitely on the list where it needs to be improved. And finally, is upgrade. Well, upgrade is a well-known issue, right? You need to upgrade from one version to another. You need to rolling upgrade the whole way. You need to upgrade from certain versions for your applications. Now, the infrastructure upgrade, from my perspective, is getting solid, but it's in the terms that you need to think about application. So it's not just about upgrade your infrastructure, it's about move your infrastructure with your application still running and all the way to the new version, but nothing broken. And so that is actually kind of a heavy discussion in the entire community. So those are the items we think that need to be improved. And those are something that we actually spend a lot of time trying to help. And that's why we're trying to have these sessions. It's about how we can help. So are we there yet?
Are we there yet?
Are we there yet? Are we there yet? I don't know, but.
How about now?
Well, like if you are like father, you will have this kind of experience in annoying, but not yet, you know. But we're getting to something. We're getting something. We start to working on something, right, Papa?
How about now?
How? Yeah, don't worry, my little Smurf. So then, I think let's start from, if you see on the right, on the top right, on top left, we will show what kind of area this is for. Like we have discussed about few items, right? So then.
So this is one that is actually ready and available now in Queens. So application credentials. And the problem this is solving is, you have an application running in OpenStack and you need it to call OpenStack APIs, and the very last thing you want to do is put your password, which is not only the password to your OpenStack, but probably the password to your email and everything else, because your Keystone is backed by LDAP or Active Directory or something. And you really, really don't want to give your password to a virtual machine running in the cloud. So application credentials are the first step in the solution to that problem. So you can generate a credential which is tied to your user account in Keystone. So by authenticating with this application credential, the application can do anything that you can do, but only in OpenStack, because you're not giving it your password. So there's probably a lot more to be said about exactly how this works, but the documentation is available online. And once again, this is available right now in Queens, so you can go try this out. And I highly recommend it. If you're running, Kubernetes on top of your OpenStack or something, and you need it, it's using the cloud provider. you need to give it credentials. Like I would recommend using application credentials rather than. I mean, the alternative would be to phone up your IT department and get them to create a service account in your Active Directory or your LDAP backend, so that you can run an application. Right? Clouds shouldn't be about that. You shouldn't have to call up the IT department to get permission to deploy an application. So this is something that can help short-circuit that and get a more cloudy experience for your applications.
Yep. I mean, for us, we we trying to develop something, and nowadays, like the new design for us, we even consider. I mean, we already trying to do something with application credential, which we will mention some of them after, later. So.
And this is the next step of application credentials. So, as I said, right now, an application credential that you create can do anything that your user in Keystone can do, subject to what roles you give it, by the way. So you can lock it down to a smaller number of roles. But what you'd really like to be able to do is to give it permissions to only do the things in OpenStack that you know that your application needs to do. So if you lose control of this credential because somebody hacks your VM running in Nova or whatever, you don't give it access to everything you can do in OpenStack. You only say, all right, this application needs to do this thing, this thing, and this thing, and that's the only thing it can do. So you're really limiting the damage that can be done by someone obtaining the credential. And this does not exist yet, by the way. So I was talking to Colleen yesterday. She wrote the application credential stuff in Keystone in Queens, and she's going to be working on this in Stein, I guess. So I don't know if it'll land in Stein or Train, but yeah. This is on the way, and it's the next step. So you'll be able to specify exactly which APIs and write down to which data is passed to the APIs. So you'll be able to get access to a specific server or a specific container in Swift or something like that, and make sure that is really locked down to only things your application needs to do.
Yeah, and then I remember years ago, there is a forum in OpenStack, and all the best developer there are talking about what is the most important thing for application developer and what we should improve. Like the only thing that comes out and considered as a brilliant idea is exactly this application credential. Am I right?
I don't remember that forum.
No, but it is.
If only the most brilliant developers were there, then I probably was somewhere else.
Well, don't worry about this guy. But it is. Check the record.
Okay, so excuse me. The next step that we'd love to do after this, and it's probably not going to happen until after we have those capabilities on the application credentials, but what we would really like to do is to have Nova actually provision credentials for you. So before you spin up a server, you can say, okay, the application running on this Nova server needs to be able to access these APIs, and then Nova will somehow provide credentials to the server. And the reason that we want Nova to get involved here is because it's pretty much the only thing that has a way to actually change the credentials. So if you put some credentials on your server, probably eventually they're going to get compromised. Like, you should probably plan on that. So what you want to do is rotate those credentials regularly so that any compromise is limited in time as well as limited in scope, because it's locked down to the APIs that server needs. So by getting Nova involved in the picture, it'll be able to automatically rotate those credentials. So your application will always be able to get the latest ones that work, and if it loses them, then that's kind of okay because they're going away soon anyway. So that's the next step, which we'd like to see happen after capabilities are added to application credentials.
Yeah. So this is still on the plan, right?
Yes, it's a forward-looking you know, past performance may not reflect future results.
Yeah. And if you really like the feature, I mean, you definitely need to reply and feedback to the upstream community to say you like the idea, and otherwise, we trying to help to accelerate this kind of a plan, but it took user, in this case, it took application developer to actually tell the upstream about what you guys needed, and which this, in our perspective, is very good stuff that should be done a long time ago.
So the other thing that you can use right now in lieu of fully locked down application credentials with capabilities is pre-signed URLs. And this the problem with this is it only exists where some project has specifically implemented it. So I think Swift is one example with the temp URL middleware that it has. Zakar is another example. But where a project has implemented this, it'll let you generate a URL which contains the things that you're allowed to do. So, you know, for Zakar, for example, you might have a URL that can only receive messages from a queue. So it can't put any messages in the queue, but it can receive messages from the queue. So it'll be signed, you know, URL action get only, and the name of the queue, and then it'll be pre-signed, sometimes with an expiration date, so you can make them expire automatically in the future. Again, so that they're limited in time, if that's what you want. And this is a URL that you can give to your application. It doesn't need a keystone token then to authenticate. It can authenticate with the signature on the URL. And this is a good interim solution until we get the full-on application credentials. This is probably how I would recommend doing stuff. But again, it only works where specific services have implemented this for specific operations. So in the future, we'll have a much more generalized framework where we can do this for everything. But right now, if this does what you need, that's what I'd recommend.
So you're saying this feature is already ready there in OpenStack community?
Yes. Again, in the projects where it's been implemented.
Yeah. I think it's a very cool feature. And this feature is actually like Zen mentioned, it's actually very heavily discussed when as a you know, we kind of like do a lot of things in heat, and for us it's like how can we best protect the user, and how can we best protect your informations and your credentials, and pre-signed URLs is something that even if it's not internal of OpenStack service, you should consider to use something like this to protect yourself as well.
Okay, so this is a fun one. Kind of moving on from the kind of low-level things available to applications. We put together this demo a couple of cycles back. I want to say Okada.
Okada?
Yeah.
Yeah.
Let's say Okada. And this is basically integrating a whole bunch of services in OpenStack to do something that I know you're all probably wanting, which is to self-heal service. So to actually notice when a server has died and replace it. And so it's taking advantage of the fact that the heat template knows how to create the server in the first place, and therefore how to recreate it. So, and again, I think we can see on this slide that you know, some of these bits are pluggable. You can have different alarms, different signals. I think the next slide has got things plugged into these boxes. Am I right?
You mean like details?
Yeah.
Yeah.
Like logos.
I might not put it in. Oh yes, we have.
Okay.
Smart.
So, basically how this demo works is we're combining Heat, Zakar, Aid, and Mistral. So AID is doing the alarming, so it's looking at the Oslo messaging bus, looking for Nova to say the server has been deleted or gone into an error state or something's happened to it. It's putting the alarms from that onto a Zakar queue. And Zakar is using a subscription to post those messages to Mistral, which triggers Mistral to call back to heat, the workflow definition on the right there, which is marking that resource unhealthy in heat. So it's telling heat, hey, I got a message from an external thing saying this server isn't good anymore. You need to replace that next time you're doing something. And so it's going to mark it unhealthy, and then it's going to initiate a stack update, which is going to cause heat to go through. When it gets to that resource, it'll say, okay, this one's not good. It's been marked unhealthy. I'm going to create a replacement, and the template sort of hooks everything back up so that the new server is hooked up to the alarms and all that kind of thing. Then it'll delete the original that was unhealthy. And you can do this multiple times. You can do it multiple times in parallel thanks to the convergence architecture in heat. So you can do multiple stack updates in parallel now.
So you mean if I'm an application developer and on top of my Nova instance, I have other things is running. Is it possible that I try to monitor those application services on top of it and trying to trigger the alarm back and act to here? Wow.
Yeah, I mean, you could, if you have your own application monitoring, then you can just plug that in place of AID here. So you could post those straight to the Zakar queue, or honestly, you could post them straight to Mistral. Just when you get the advantage of the Zakar queue is you can use the pre-signed URL, give that to your application monitoring and have that hit it, and then it will authenticate to Mistral with a trust, which is set up at the time that you create the subscription. And so you can have your own application level stuff triggering this as well.
Yeah, cool. I mean, this happened to like one of the example that we're trying to use in pre-signed URL to protect, and that's why we think I put this diagram like this, because it actually depends on how what you want to metering, what is your service. It can be an application, it can be a low-level instance, and it can be so high-level as you define as you like, and how you metering it and how you want to handle a signal, and how you want to trigger a fixed job. And those features here are already ready in OpenStack. So you can try to use OpenStack service for all of them, or you can try to replace one of them and use your own service. Just make sure that it can communicate with each other through this kind of a workflow.
Yep, and going back to your earlier point, Rico, about integration between projects. In trying to implement this, I found a whole bunch of really subtle bugs where each project did everything that it should, but when you tried to marry them up and kind of build this feedback loop, there was like a little mismatch. And so I went through and fixed a bunch of those. So this now works very smoothly, starting, again, as we said, in Okada. There may be other things like that in OpenStack, and we're kind of relying on you guys to tell us what they are. But those are the kind of things we can improve and fix and make the application development experience better.
Yeah, cool. And the vision?
Oh, so this just merged today, which is exciting. One of the things I've been working on in the technical committee is kind of putting together a vision for what we think an OpenStack cloud should look like in the future. We're not limiting ourselves to what OpenStack does right now, but we're trying to set a goal for where we're headed and make sure everyone in the community is going in the same direction. So one of the things we tried to do in this exercise is actually to define what a cloud is, because not everybody has the same definition.
Yeah, I mean, everybody's different. I got different definition for what you guys TC should do.
So the two things we said that clouds must be able to do. Number one, which we all know, clouds must be self-service, right? It goes back to what I said before. Like, you shouldn't have to go call up your IT department and ask for permission to deploy an application, whether that's asking for a service account in LDAP or anything else, right? So clouds are self-service, and that means they need some other features like multi-tenancy and that kind of thing to make it safe to be self-service. That's the first thing, and the one that everyone kind of agrees on. But the second thing is clouds have to be a resource for the application, not just for the user. So your applications are running 24/7. You want them to be able to access the cloud and use the cloud when you're not sitting in front of your desk clicking buttons. And that kind of feeds into a lot of these things that we've been talking about in terms of requirements for application credentials, locking down the capabilities on the application credentials, having a secure way basically for the applications to authenticate to the cloud.
Yeah.
So this is something that is becoming more visible in the OpenStack community, I hope, through initiatives like this. And I think we're starting to get on the same page in terms of figuring out what we need to do in the future to make sure that that OpenStack is a first-class kind of platform for developing applications on. So.
Yeah, and that's exactly why we put it here, because it's like we want to send a message out that OpenStack is really up to trying to help the application to get the better infrastructure, and we're not just trying to do the downstream. Wow, that's like very cool stuff. And our next stop is to expose the SIG and working group, which is still on, we are still on the plan. We have 4 rounds this week as well. And what we think about is, so you are considered as a user or operator on top of us. But when you have a feature get into OpenStack, it's not always getting a well feedback. It's not always getting go to the right person. So how about we have a flow for you? You can put your story, you can put your bug, you can put your report into some place. And we got people like have the interest to help you, like SIGs, like working groups, that they are there to help you to make sure your requirements might and will go to the right person. And even more awesome is about they can help you to direct those tasks into different projects. I mean, people in the siege might be a project PTL, or might be a very experienced developer. They got a knowledge about what this might go to which project, which you not necessary to have, and you don't want to have in sometimes because you just want to do your application. And that's why this idea is come out. And unfortunately, nowadays, well, you absolutely can do that. We have SIGs, so you're trying to. If you got any like scenario, like self-healing scenarios, you got Kubernetes scenario, find those SIGs, find those working groups. They're going to help you. What we put here want to do is, we want to push TC, UC, and everybody in the community on the same page to actually define the flow and define the guideline to help you. And it's not all totally ready yet, but we were trying to push it. And the multi-cloud orchestration is something that we think is a very exciting stuff as well, which already have patch in Heat already. That is you can call orchestration, you can call Heat in one of your OpenStack clouds, and to ask that to create a resource in the clouds, and you can use the exactly same request and to create another stack in another OpenStack clouds. That means if you got the knowledge, you will know it's a structure like a nested stack, means a stack create another stack. But in this case, the trial stack is actually a stack from another OpenStack. That means you can control all of your OpenStack cloud from a single cloud. You can control from there, and what is the connection between? You can using application credential to make sure they are secure. And in the implementation we propose is also using Barbican to actually make sure whatever you store in OpenStack for your information, your authentication information, is actually secure store. It's not randomly put at any database place to get access.
I like how you worked application credentials in there.
Yeah, you can get application credential in it. The amazing part is you can get whatever currently Keystone supported way for this. So it is not pinned at all. You just have to create a stake as usual, but this time give it a credential secret. Now the development detail is already there in the upstream. It's not merged yet, but we're kind of looking forward to get merged.
It'll merge as soon as I review your patch, right?
Okay. Now there's Zen talking about, so
you're behind on your bribes.
Okay. So there's a video record for you. I will be very happy. Haha. And the next thing we're talking is about auto-scheduling. Now we have a forum session today as well to talk about how we can have better auto-scheduling improvements for you. I mean, by talking about auto-scheduling, we're not just talking about heat. Yeah, we're not just talking about heat. I mean, we're talking about heat, sending, right? We're talking about Kubernetes or try to have an auto-scheduler as well, which it got a project called Kubernetes Autoscaler, and it's supported using Amazon is supported using Azure is supposed using Google Cloud, but it's not supporting OpenStack yet, which is exactly a missing piece. We're trying to working on that as well. Now we have like a dev page there already, but what is needed is that we definitely will trying to keep pushing ourselves to implement it. Now we're going to try to support more. Like in this case, we're talking about directly talk to resource group and scale, and we also consider from Kubernetes part when the pod needs to scale. We can also directly talk to Magnow, and Magnow will do the scale job. But anyway, it's still on the plan. Sorry about that. We always wish to tell you it's ready, but usually when we mention something, it's not. But keep mentioning, and we will be there. So this is what I'm talking about, to have improvements, right? To improve the sending, to improve the heat, to make sure the user get a single terminal, and to make sure the user get the correct documents and correct way to do it. That's also what we already promised this week. We're going to have documents for you. And the other thing we're trying to promise as well is we're trying to have a new siege. It might be like auto-scaling siege, but let's see. We're going to trigger a discussion. If you are interested, join, or if you got ideas, join us on the mailing list, and we will figure out what is the best for people on top of OpenStack.
All right, you have 1 minute to talk about hidden Kubernetes.
Yeah, I mean, but it's like, so it's like we got 1 minute, and it's just like this diagram, you know, like that.
You're still going to stare at this diagram for 1 minute.
Yeah, that's sending and heat, but we're going to figure out what is the best mascot for the new siege. Don't worry about it. So we got like, so we kind of like run out of time, but let's briefly describe some of the features. So one of them is to have heat control Kubernetes, and using heat to, you can using the heat resource to actually customize your own resource type. So Kubernetes is definitely one of it. How about you can, on top of heat, you can define all of your infrastructure from all the way to the Kubernetes. You don't have to create a Nova, using Nova to create a Kubernetes and jump out and using some API to create your pod. We kind of consider to have this idea, but it's just planned yet. It's just planned.
Once your Barbican code merges for the multi-cloud
you're getting
stuff, then we can use it for this.
Yeah, we're on the way, man. We're on the way. And so is Ansible as well, right?
Yeah, I could see us doing the same thing for AWX, which is the upstream project for Ansible Tower.
Yeah. So the new kind of way is capable to merge to current OpenStack infrastructure. We just have to figure how we can do it. So yeah, that's the most thing we're trying to do. We're already doing, and we are still on the way. And so.
So we didn't leave you any time for questions. I'm sorry, but we will stick around after this. And people who are watching on the web, you're out of luck. Sorry.
Okay. Thank you.
Thanks.